is better. And distance cannot be 0, but displacement can be 0. Distance is the actual path, and displacement is the shortest distance. And distance can be represented as speed into time, displacement as velocity into time. That's it.
Samhita, what about you? What you wrote?
At the same points, I wrote distance is positive, it's a scalar quantity, it cannot be 0, and it's the total distance traveled, and displacement is the shortest, it's can be positive, negative, or 0, and it's a vector quantity.
What was the fourth point you said?
Sir, it cannot be 0. Oh, you wrote that. Or it's the this is speed by distance by time. No, sorry, sir. It's wait, I got confused.
Speed into time.
Yes, speed into time. Sorry.
Shadab, any other point?
No, sir, same thing.
Shortest path, other way to define is final minus initial. Now, one more point is that distance is always more than or equal to displacement. Add it. Distance should be always more than or equal to. It cannot be less than. Right? So distance is always more or equal to displacement. Okay. Any other thing we can write?
Sir, displacement is always a straight line.
No, I say something here, right? Distance is always more than or equal to displacement. Did you are you agreeing with this statement? You just said yes, yes.
Yeah, I mean, displacement cannot be greater than distance. It's either equal to or less than.
Okay. So everywhere, right? So if I ask you to find a displacement for 3, 4, and some numbers, find out displacement
5.
from A to C, B. Much 5.
5.
Yeah, it's obvious, right? Under root 3 square plus 4 square. 16, 9, 25, 25 under root 5. That is 5. So if you take any direction, like if you move in this path or move in this path, anywhere you move. So shortest path will be this one. You can move any direction. So obvious. So distance should be eraser. here. What's happening? So it's always equal to displacement. Now speed. As usual, distance travel per unit time. Distance travel per unit time. So formula will be like speed equals to distance by time. Uniform speed. What will be uniform speed? What will be uniform speed?
So when an object
Equal-
maintains the same speed from initial to final point.
Okay. Fine. You were saying something? Yeah. Aditi, you're saying something?
No, sir, same thing.
Same thing? So yeah, that's obvious. Uniform speed can be also a uniform motion. Yeah, object is said to be moving with from speed uniform speed if it covers equal distance in equal time interval. Equal distance in equal time interval. That is your uniform speed. Now non-uniform, opposite of this one. As we wrote already, uniform motion, non-uniform motion, we wrote already. So similar. So it covers unequal distance in equal interval of time. Okay. You can write for non-uniform also, same way. You can write it in your own words. That's okay. Done? Okay. Samhita?
Done, sir.
Then write for instantaneous speed. Feeling sleepy? What will be instantaneous speed? Yeah.
The speed of an object at any given point of time.
Speed of an object at a given time or a particular time. Now from here, actually, we will write some formulas now on. So it will be, see how to find this particular time. How will you measure that? What is the particular time for that one? How will you exactly find that? Okay, this is exactly speed of this time.
So you're gonna have to differentiate it so that you find the slope at that point.
Yeah, we'll differentiate in the sense we'll find the difference. What was previous and what is now. Because exactly we cannot find it at particular instant. If we are traveling in a car, okay, how we'll know that exactly? So what is that? We'll find a difference between those 2 points. So that will give you difference in distance and difference in time. That will give you instantaneous speed. So in short, we'll write here V instantaneous equals to limit of this instant, that is at starts from t equals to 0 delta s by delta t. Now to remove this one, we have ds by dt. So what we are going to do, we will differentiate distance with respect to time. Okay, but this as we'll use for displacement also, right? So what we'll do, we'll change this to x. Distance will take as x and displacement will take as s. It's a variable only, any variable you can take. Okay. Now next is our average speed. Now what will be the average speed?
Total distance by total time.
Total distance by total time. Ratio of total distance time. So V average equals to delta x by delta t. So we'll change this to x. So it will be easier because we will take for displacement also. We need some variable for displacement. So dimension and unit. Write it. Write yourself. Come on, dimension and unit. That you already know, right? Kirtana, are you connected?
Yes, sir.
Okay. So what's the dimension of average speed?
I don't know.
Seconds.
I cannot hear you.
Seconds, sir.
Seconds. Okay. A unit.
Sir, meters per second.
Meter per second. So dimension will be let
M0.
L1 t minus 1. So let it be whatever speed it is, average, instantaneous, uniform, non-uniform, or just speed, or whatever speed it is. It has speed. That means dimension is the same. Same goes for force, whatever force it is. Friction force, this force, that force, gravitational force, and whatever force we are going to study. Same dimension, same unit. Same goes with energies also. All energy, same dimension. All type of work, same dimension. Okay, that thing is changing. Okay, it's different type of force. Whenever we are standing here, we are studying about gravitational force. Whenever we are pushing, frictional force, or applied force, or whatever force we are studying. So force unit will be same. Whatever we are using with applied or friction or gravitation or blah 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 thing. So it is just force. Same thing. Let's write about velocities. Quickly, everyone write. What is velocity? Then uniform. Then non-instant. Average. Then we'll have some graph. Done?
Yes, sir.
Ratio of what?
Displacement and time.
Total displacement by total time. Done? Everyone? Samhita?
Yes.
Kirtana? What about this both? Where you went? Dimension of this one? Dimension of this one?
Sir, same.
M
ML might.
0.
Sorry, sir.
Unit? Okay, you're waiting. He will say like that.
Meters per second.
It's okay. Everyone together can answer. Because it's just 4 people, like small class. I'm handling here 300 students, so not a problem for 4. Okay. So this thing's now clear, everyone, right? Speed, velocity, average, instantaneous, formulas, all that, right? Okay. Kitana wrote, right? Completed? Now something too important like a average velocity can be 0. It's possible to get 0. It's possible to get average velocity 0. But can this average speed be 0? What do you think? Can we say that average speed will be 0? Is it possible?
No, sir.
No? Why do you think so?
No.
Okay, what's the reason?
Well, since distance cannot be 0, then the entire numerator cannot be 0. Hence, the value cannot be 0. However, displacement, let's say you traveled and you came back to the same spot, your displacement is 0. Hence, your average velocity becomes 0.
Okay. Fine. Like some hypothetical situation, if I give you like a distance I travel will be same, then
Same as in,
he's traveling same distance. Suppose he's in uniform motion, then
even
Sir?
if you're in uniform.
yeah.
In that case, you should get 1, right? Not 0.
Will I get 1? It's just a hypothetical case. Okay.
Sir, it's the opposite, right?
Hmm?
Average velocity can be 0. Oh, sorry.
Yeah. See, if I take a positive value of average velocity and positive, obviously speed will be positive, but if I take average speed, will the ratio be equal to 1? This can be equal.
It's possible.
See what I said previously, we wrote something here, right? With the green color, I remember. Yeah, distance is always more than equal to displacement.
Yeah, so it's possible. If it's equal to, then anything divided by itself is just 1.
Okay, and what is other thing possibly? It will be more than 1 or less than 1?
Less than 1.
Less than 1, are you sure of it? Amita, what do you think?
I think it can be 1, but I don't know how.
Okay, it can be 1. Okay, fine. I agreed. So one possibility we saw, it can be 1. So
Yes,
it can
sir.
be
1
more
or
than
less than 1.
or less than. More
So
than or less
Maybe,
than.
0 and
I think I got it. How can be 1? Maybe it's when it's traveling along the same path, because then the displacement and distance would also be equal, and the time taken will also be equal. So I think it can be 1.
Yeah, it can be 1. That is agreed. Now, second case, it is more than possibility or less than possibility? More than 1 or less than 1?
More, I think, because speed can't be 0.
More than. No, I'm taking positive values only. This average velocity, I'm taking mode of average velocity. In short, I'm taking is positive values. So will it be more than this ratio? Average speed and velocity ratio will be more than 1 or less than 1? You said equal to 1 possible. Fine. They are equal. Okay. But it can be possible more than or less than.
So less than.
Yeah.
Because speed can be greater. The greater the speed, the denominator is greater. Hence, the value becomes lower and lower. So it's somewhere between 0 and 1.
Okay. What do you think, Aditi?
Sir,
Yeah. Sir, क्या आगे तो बोलो. अरे, I'm waiting.
sir, 1 minute, sorry.
Okay, 1 minute. ठीक है. Kirtana, what do you think?
Sir,
Yeah.
why can't it be less than 1?
Are you asking or are you giving your opinion?
No, I got it.
Okay. What is it?
It can be 1
Or
or it can be more than 1.
more than 1? Okay. Why do you say so?
Because speed is in the denominator. So it can be any value, but velocity
Speed is in
different
denominator.
displacement. Yes, sir. No,
Think
sir, why
again.
can't it be less than 1?
Eh,
Sir, I'm confused.
ठीक है, ठीक है. What is this sign?
less than.
So if I take positive value of this one, so instantaneous speed and instantaneous velocity, will it be equal?
Possible.
Possible or always? Yes, Kirtana. You're saying something?
Not always it will be equal.
I didn't hear.
Sir,
Yeah.
when considering instantaneous speed or velocity, we make, whatever the points we take, they're super close, right? So that we get an accurate measurement of the slope at that certain point.
Okay.
Well, then there's a difference between initial and final, although it's very minute. Then can we consider it as equal, or do we have to go to the minute details?
No, we will consider equal. So
Alright.
instantaneous velocity and instantaneous speed will be equal. Okay, so done this one, right? So when can we say object it's in moving? As you see your fan is moving, how can you say that this object is in moving? It's what is actually happening here?
If its position changes with respect to time.
Its position is changing with respect to time. So with the time, it's keep on moving and moving, rotating. So it's making a like circular motion, right? Fine. Now, if I consider an object in curvilinear motion, so how can I explain that object is in curvilinear motion? What is curvilinear motion then?
The object is traveling in a curved path.
Curved path. Okay, object travels in a curved path. That is curvilinear motion. ठीक है. So if I want to explain something here, a particle may be moving in some constant speed to move this one here. But variable velocity. So object, its velocity is variable. So it can be said that curvilinear motion. Now, if body covers half distance with v1 speed and remaining half at v2 speed, remaining half. Next half. So what will be its average?
V1 plus V2 by 2.
Other half, next half. V1 plus V2 by 2, okay. But if I say average velocity will be 2v1 v2 by v1 plus v2. Now same thing, if I add one more thing, like if object covers first 1/3 of distance in some speed as we wrote here v1. Same manner, remaining third portion this speed and remaining portion in v3. And what will be its total speed? Average speed, I mean. 1/3 portion as v1, remaining 1/3 means next 1/3 as v2 and or next 1/3 as v3. Average velocity will be 3v1 v2 v3 by v1 v2 plus v2 v3 plus v3. What we left here? 1 2 2 3. What we left here? 1, right? There is 1 less. Okay. So v3 v1 or v1 v3. But if body travels in uniform speed v1 for time t1 and speed v2 and for time it is not writing properly. Then speed will be, or average speed v dash will be something v1 t1 plus v2 t2 by t1 plus t2. Do we have time? Okay. No, we don't have, right? What's your next class? You have any next class?
Chemistry at
We have class. Let me check. Okay, let it be. I was thinking to start numericals, but let's do tomorrow. Tomorrow is Tuesday, right? Tomorrow we don't have class. We have Wednesday. Tomorrow I have another class. Fine. We'll do it on Wednesday. What time you are coming from school, Aditi?
What's it?
What time you are coming from school?
5:30, sir. 5:30.
Oh, 5:30. And you, Samita?
But it's a college, not a school.
Okay.
Sir, I come back by 4.
For you come by 5:30. Sada also coming by 5 o'clock, right? Around 5.
No, sir, I get here minimum 5:30, maximum 6. If there's traffic and rain, then 6.
Okay. Then you need to relax sometime, right? Half an hour at least, yeah. Okay. And what about Kirtana? What time you come from school or college?
It will end
College.
at 5:30, sir. I'll come by 6.
Oh. And instantly your time starts, right? Okay. Let's see if you guys want, like, we will change it to 6 instead of 6. We'll have some 6:20 or something. Because you're coming from school directly, you're starting your class, then everything will patch up.